a void where matter should exist. It appeared as an absence so complete that it drew attention by refusing to behave like empty space ever had before, a region where matter should have gathered, evolved, and persisted, yet instead left behind a silence that no model had predicted. The universe, which rarely wastes material, seemed to have erased something without leaving a trace. To understand why this void still troubles scientists today, we need to revisit how structure forms in the cosmos. Galaxies, clusters, and vast filaments emerge because matter follows gravity, collecting wherever conditions allow. Modern cosmology relies on this principle, mapping the universe as a web of density shaped by predictable forces. Emptiness exists, but it has rules. This void did not follow them. When surveys first revealed a region, it appeared as a gap far larger and cleaner than expected, interrupting structures that should have continued uninterrupted. Statistical models suggested that random variation could not easily account for its size or shape, yet no violent event or visible process explained how so much matter could simply be missing. As observations improved, the mystery deepened. The surrounding regions behaved normally, with galaxies moving and evolving as predicted, while the void remained stubbornly empty. There were no signs of displacement, no accumulation elsewhere to balance the absence, only a hole in distribution that defied conservation. What made the discovery unsettling was not just the missing matter, but the implication that the universe could organize itself in ways that left deliberate-looking gaps, regions where familiar rules paused without explanation. The void was not chaotic. It was precise. And in that precision lay a question that refused to stay quiet. How could emptiness itself become structured in a universe defined by attraction? As researchers examined the void more closely, explanations that once seemed sufficient began to unravel, because the absence of matter was too coherent to dismiss as statistical fluctuation. Cosmological simulations were rerun with greater resolution, incorporating every known variable that could influence large-scale structure, yet none produced a gap with the same clarity and persistence observed in reality. Attention turned to the early universe, where small differences can grow into dramatic outcomes over billions of years. Scientists explore whether tiny variations in initial density could have expanded into voids seen today, amplified by cosmic inflation and the long pull of gravity. While these models produced emptiness, they failed to reproduce the sharp boundaries and scale that defined this region. What made the problem more difficult was what the void lacked. There was no evidence of violent evacuation, no signs of matter being pushed aside by massive events or energetic processes. Galaxies near the edges showed no unusual motion, behaving as though nothing extraordinary had occurred nearby. The universe had not torn matter away. It had simply never placed it there. As hypotheses multiplied, some researchers began considering influences that did not interact with matter in familiar ways, forces that could shape distribution without leaving visible fingerprints. Others questioned whether assumptions about uniformity on large scales were too optimistic, and whether the universe allowed for regions governed by conditions fundamentally different from their surroundings. The deeper the analysis went, the more the void felt intentional rather than accidental, not in purpose, but in structure. It existed as a stable feature, maintained across cosmic time, resisting the gradual infilling that gravity should have enforced. Emptiness, in this case, was not temporary. It was sustained, and that realization pushed the mystery beyond missing matter toward a deeper challenge, understanding how nothing could persist so effectively in a universe built to gather everything. The conflict intensified as the implications of the void reached beyond missing matter and into the foundations of cosmology itself, because explaining its persistence required questioning assumptions that had long been treated as universal. If gravity naturally pulls matter together, then emptiness on this scale should be unstable, slowly eroding as surrounding structures bleed inward over time. Yet the void remains sharply defined, resisting the very forces meant to erase it. Some researchers propose that the region was shaped by influences that counteracted gravitational accumulation, subtle effects that operated across vast distances without leaving conventional signatures. These ideas were difficult to test, relying on indirect consequences rather than observable interactions, and they challenged the notion that matter alone determines cosmic structure. Accepting them meant expanding the inventory of forces shaping the universe. Others argued that the void revealed limits in how simulations represent reality. Models are built on averages and probabilities, smoothing complexity into manageable forms. But rare configurations may survive precisely because they are unlikely. In this view, the void was not a failure of theory, but an extreme outcome that exposed how incomplete statistical expectations can be when applied to a single universe rather than many hypothetical ones. What made the debate especially tense was how deeply the void cut into confidence. Cosmology relies on the idea that large-scale behavior can be understood without accounting for every detail. Yet this region suggested that overlooked factors might dominate under specific conditions. The universe was not merely noisy, it was elective, allowing structure and absence to coexist in ways that defied intuition. As discussions continued, the void became a symbol of discomfort. It represented the possibility that emptiness could be as informative as presence, and that what is missing might carry as much meaning as what remains. In confronting that idea, scientists face a difficult choice: either preserve familiar explanations or allow absence itself to reshape understanding. The question was no longer where the matter had gone, but whether the universe sometimes builds structure by deciding where matter will never be. The climax of the story arrived when the void was no longer treated as an error to be filled, but as a feature that demanded explanation on its own terms, because its persistence across cosmic time made dismissal impossible. The absence of matter was not temporary, nor was it collapsing under gravity's pull, and that endurance forced scientists to accept that emptiness itself could be stable under conditions not yet fully understood. This realization shifted the conversation away from searching for lost matter and toward understanding how large-scale structure is truly shaped. The universe was not simply a system that gathered material wherever possible, but one that allowed exclusion as well as accumulation, permitting vast regions to remain empty without violating overall balance. The void did not contradict the universe's rules. It revealed how incomplete humanity's interpretation of those rules had been. The resolution did not arrive as a single theory, but as an expanded framework of possibility. Models began to accommodate the idea that cosmic structure could emerge from both presence and absence, shaped by interactions that did not always announce themselves through visible matter. Emptiness became a clue rather than a failure, pointing toward influences that organize space as much by omission as by attraction. In a broader sense, the void changed how scientists think about meaning in the universe. Discovery is often associated with finding something new, yet this region demonstrated that what is missing can be just as powerful in reshaping understanding. The universe had not hidden matter here. It had revealed a boundary where expectation no longer applied. Today, the void remains where it always was, silent and unchanged, continuing to challenge assumptions about how the cosmos builds itself. It stands as a reminder that understanding does not always come from addition, but sometimes from recognizing the significance of what is not there. Subscribe to join the journey.